Hi, everybody. Welcome to the living room, our bi-monthly sessions for conversation and information sharing on various topics related to sustainable jewelry practices. We cover topics from practical tools that can be implemented in your jewelry practice to more in-depth learnings about artisanal mining, for example. Today, we're going to be discussing carbon footprint considerations for jewelers. And as always, we'll have a blog post summary and the recording available on our website. I'm Anna Brazetitan, Consultant and Education Director at Christina T. Miller, Sustainable Jewelry Consulting. And I'm glad to be here with all of you, along with my teammates, Christina Miller, our founder and lead consultant, and Cecilia Echeverri, Consultant and Operations Director. Through our educational and consulting services, we provide strategy, guidance, and education on responsible sourcing and sustainability in the jewelry industry. You can find out more about our services at christinatmiller.com, and you can always feel free to reach out to us with your questions or suggestions for future living room topics. We want to say a big thank you to those of you who've been able to contribute to making these sessions happen through our Pay What You Want option on our website, as well as to everyone here who's showing up for the conversation or anyone who's listening to it down the road. A little bit of housekeeping. This conversation is being recorded and will be in the public realm. So we encourage your participation through the chat, and we may read some of the questions or comments out loud. But for best sound quality for the recording, please make sure that your microphone is on mute. And remember, this is a kind community space, so please be respectful of everyone's privacy and personal space if you are using the chat. Our next living room session will be on July 26th. In July, we will have it on the fourth Friday of the month, so make note of that. And please sign up for our newsletter to receive a reminder about that, as well as to receive the takeaways from this session. You'll find the link in the chat or in the caption below if you're watching this later. So now I'll hand it over to Christina to start the conversation.
Welcome, everyone. It's been a couple of living rooms since I've been here, actually. Cecilia and Anna have been leading the way, but I'm really thrilled to be here and welcome David Jaber, our very special guest today. This is the information that we're covering today is something that seems mysterious to many of us. And we know with conversations that we've had with all of you that understanding GHG emissions of the jewelry industry and then our specific role therein is of interest to you all. And hopefully what we're learning from David today is information that we can continue to build on, because this is an overview session rather than a deep dive, for instance, into like going really deeply into gold or going really deeply into colored gemstones, which we're going to explore further in the future. So welcome, David. David is the owner and founder of Climate Positive Consulting, a certified B Corp, which we have also done a living room about, that advises businesses in carbon footprint analysis, climate strategy development, and GHG emissions reduction in line with science-based targets and net zero goals. Those two terms, science-based targets and net zero goals, are real defined terms that we use around GHG emissions. So it's important for us to have a good understanding of what those mean. David's been a business consultant for over 20 years, is a Project Drawdown Fellow, and the author of Climate Positive Business, How You and Your Company Hit Bold Climate Goals and Go Net Zero. He's worked with over 200 companies, and we are very thrilled to have him with us today. The way the session's going to work is we'll have a bit of a presentation from David, and then we'll have a Q&A. So we look forward to handing it over. Welcome, David. We're really grateful for your time today and sharing with this very niche community around GHG emission interested parties. So thank you very much.
Thank you both, and thanks to everyone who showed up today. I guess most industries might consider themselves niche, but there's also sort of a small and medium-sized organization component to it, and kind of all the specifics with the jewelry industry, certainly. I think part of the reason that we're all here one way or another is just that interest in business carbon footprinting has really exploded, particularly just in the last 5 years, but it's kind of built up kind of over the decades. So I do want to discuss the why of that and why business climate action, but only briefly, as since you've chosen to be here, that at least suggests you're already on board. And that would be a prelude to spending most of our time on the how accounting is done, with an eye towards small and medium-sized businesses and kind of jewelry specifically. And so just to very quickly, I think, just run over the why of this. From my lens, there's now this entire ecosystem that's around us and even within us as businesses, if I might speak from sort of a business perspective. Even if some of you are like individuals or sole proprietorship, there's some sort of business function there is my assumption. There's this entire ecosystem that's sort of mandating climate action. And each of the aspects of what I'd call this ecosystem have their own means of influences, whether that's customers, nonprofits, governments, or even employees. For the companies that I've been involved with, I'd have to say that the number one reason companies get involved in this arena is customer demands. So particularly larger companies like a Walmart or a Microsoft or a Target or Costco, they've been asking their suppliers for years to disclose their emissions, and that's brought a lot of organizations into the whole practice of carbon footprinting. And you might not be sort of supplying kind of one of those companies, certainly, but part of the reason there's been this huge uptick more recently has been, from my view, attributed, or something you could attribute to the rise of the ESG investor, if you've heard the term ESG. But essentially, those controlling the purse strings indicate, or at least indicating, that they are interested in the environmental and social responsibility of their potential investments. And that's drawn attention in a very different way from leadership and boards of directors than was the case previously. We could also certainly get into a discussion of whether we expect these voluntary drivers that I've just described to be adequate, or whether we expect or even require government regulation to achieve broader climate goals that have been set out. Most efforts I've seen to date are voluntary, but the landscape of regulation is changing quickly. And we're now seeing more companies required by governments to disclose their emissions and climate risks. So many of these drivers may not affect you directly as a small business. So the regulations I'm talking about are mostly for companies that are like $1 billion in revenue and larger. And like we said, you might not be supplying to some of these companies that are starting to make demands. But if you're in the value chain of some of these companies, you can get swept up in the commitments and requirements. And the general premise here is that it's just wise to be proactive rather than wait and create a disclosure crisis. And so that's a huge portion of the reason that we see kind of companies being proactive around carbon footprints, carbon accounting. And I think it's also helpful to remember that carbon footprint, carbon accounting isn't the end goal. Actual reduction of the footprints and the risks and liabilities you're creating is. But accounting is kind of a first important step because it allows you to get a handle on your contribution to the problem. Where you're contributing to the climate crisis can be viewed as a risk to your company. And so as part of this process, you identify where your hotspots are in your operations and value chain, how much emissions you're generating is also identified through this process of carbon footprinting or carbon accounting. I refer to carbon accounting, carbon footprinting, greenhouse gas accounting, greenhouse gas inventory. It all is essentially referring to the same thing of understanding the numbers and your contributors in a quantified way. And then, so that's one part of it. Another part of it is to investigate the policies, projects, and programs that can help you move forward. And these can be particularly helpful for small businesses that have fewer resources and bandwidth to tackle climate action. So I'm not planning to get into a lot of detail about the programs and challenges, but I think it's something to kind of keep in mind, and we can maybe talk about that in the Q&A. So with that, we're just going to touch on the fundamentals of accounting to start with. So greenhouse gases are the core of what we're tackling in climate strategy. There are 7 greenhouse gases that you're required to track by the international standard that governs emissions accounting, which is the Greenhouse Gas Protocol. And most businesses only have to deal with 4 of those greenhouse gases, most notably carbon dioxide. And not to really get into the science, but the whole reason they're greenhouse gases is they just effectively trap heat in a way that many other gases don't in the atmosphere. So the first real step with accounting is to determine your organizational boundaries. And we'll talk about that in depth in a few slides. But once you've done that and you've identified boundaries, the emissions that occurred from directly within those boundaries is referred to as scope 1. And that's typically coming from the facilities in vehicle fleets that are the main greenhouse gas generating assets kind of within your boundary. So you could think of scope 1 emissions as literally coming from smokestacks and tailpipes, along with some escaped fugitive emissions. Scope 2 is a type of what's referred to as an indirect emissions. And for most companies, their only scope 2 is electricity. The idea there is that you're making decisions from within your boundaries that affect utilities, but the emissions happen at the other end of the wires at the power plant. And then there's scope 3, which is the remaining indirect emissions. And those are all the emissions from what is typically called your value chain. So if you're creating jewelry, there's this entire chain of raw material extraction and processing, packaging and transport that's needed to get material to you, as well as your own packaging, product delivery to customer downstream. For some organizations, they also have to look at greenhouse gas footprint for the use of the product and end of life. With jewelry, there's not really a use phase of it because jewelry doesn't need other energy or other inputs to it, but there can be other sort of downstream impacts that you also want to look at as part of your value chain. So all the greenhouse gas emissions associated with that effort are scope 3 emissions. And maybe at the risk of getting a little too confusing, as authors of a recent Harvard Business Review article put it, all emissions are essentially scope 1 emissions somewhere. So this, what you're referring to as scope 2 emissions are actually the scope 1 emissions of your electric utility. And a lot of your scope 3 emissions would be scope 1 emissions at your supplier sites or kind of downstream warehouses, depending on who you're supplying. So whether specific emissions fall within one scope or other, in part depends on your frame of reference with this. And then we'll also just want to define some acronyms. EF refers to emission factors. And these are the factors that are used to convert units of some greenhouse gas source into the greenhouse gases themselves. So if you combust 1 gallon of gasoline in a vehicle, the emission factors will tell you how much CO2 and methane and nitrous oxide that creates as 3 key greenhouse gases of concern. Global warming potential then tells you how much impact each of those greenhouse gases have compared with an equal amount of CO2. So you can think of this as CO2 equivalents. And what's behind this is that different greenhouse gases actually have a different level of warming impacts. Some trap more heat than others. So the global warming potential of CO2 by definition is 1. And then the latest Intergovernmental Panel on Climate Change, or IPCC reports, and this is the body of thousands of climate scientists that have been looking at climate for the last 30 years. They tell us methane has a global warming potential of 30, and nitrous oxide has a global warming potential of 273. And it's, again, just a measure of how effectively the gas traps heat. And so all these things in combination, emission factors, global warming potentials, and the data you have on greenhouse gas sources like gasoline and kilowatt hours, all of that allows you to report emissions in metric tons of carbon dioxide equivalent, or MTCO2e. And you can think of that as the currency in which we measure carbon footprint. And then this diagram you may see all over discussions of carbon footprint, this comes from the Greenhouse Gas Protocol, and this graphically depicts what I just described. So the 7 gases are shown in the clouds at the top. Scope 1 is in the center arrow, and you see facilities and vehicle fleets is usually the things within your boundary that you're looking at that generate greenhouse gases. The curved arrow in the upper left is utilities like electricity, and then all those other categories of scope 3 are shown in the lower left and lower right. So as Greenhouse Gas Protocol is defined it, there's 15 different categories. So like purchase goods and services, capital goods, fuel and energy related activities, and everything else that you can read in the 2 curved arrows at the bottom. So I won't read them all off, but those are how scope 3 is usually defined and broken down. So it's a little more easy to tackle when you're looking at kind of quantifying the result. I had mentioned the first step was to define your boundary so you know what falls within scope 1 and scope 2. And I tend to think of these as tests. So on the right, you have the test of operational control. And many organizations that I've worked with use this. This is the one I most often am using. But essentially, if you're manufacturing a product, you operate facilities and potentially fleets of vehicles, whether you own them or you lease them. And those are the assets over which you have operational control. And that's what you would be consider as falling within your scope 1 and also electricity for scope 2. There are also tests of financial control and equity share. It's technically, I guess you could use financial control. I think of this as more appropriate for holding companies, but basically for businesses where you are able to make the financial decisions, you would include those in your portfolio of emissions. So if you were what would be referred to as a holding company and you own a few other companies, if you have 51% ownership and you're essentially calling the shots, those would fall within your scope 1, scope 2. If you only had a fractional portion of ownership of some of those and you didn't have that level of control, then you wouldn't count them. Equity share then is for investors where you have partial control, and then you can say, well, if I only own 10% of this organization, then I'm only reporting 10% of their emissions. And then these owned organizations presumably have to have some way of coming up with their emissions, and they would frequently be using operational control or financial control. And for relatively simple organizations, financial control and operational control could be exactly the same thing because you only financially own the assets that you're operating. So hopefully that wasn't too esoteric, but it sort of speaks to needing to define the boundaries for analysis in the first place, which is pretty important before you do the analysis. So in moving on from setting boundaries, and I guess another portion of that are implied in that is identifying all the greenhouse gas sources within your boundaries, but then you're finally in the data collection portion of the work. So for carbon footprinting, you'd be collecting data on gallons of gasoline, kilowatt hours of electricity, therms of natural gas, and all the other available data you have on greenhouse gas sources. So you collect all the data on these sources. You do quality control to make sure you have everything covered, and you can explain any gaps, omissions, or anomalies, just to maybe touch on sort of the data quality portion of this. With that collection done, you're then in what I would consider the core of carbon footprint development, where you use the emission factors and global warming potentials that we just looked at and convert all this collected data into the metric tons of carbon dioxide equivalent. In emission factors, the whole reason you have emission factors here, maybe just to sort of step back, is ideally on your facilities, you could have little monitors that would tell you exactly how much CO2 and methane and nitrous oxide are escaping your facility. But no one has that. That's not the case, and I don't see that happening in the near term. So what we do have are these emission factors that essentially would be developed by someone looking at the combustion of a gallon of gasoline and actually measuring how much gas comes off of that. So rather than you on your vehicle or on your facility needing monitors, you can say, okay, for every gallon of gasoline that we used that we combusted technically, here's what the emission factor, here's the emissions that are coming off of it. So it's sort of a proxy. It's not a direct measurement, but it's a pretty good proxy for that case. And we'll get into other cases where the proxy maybe isn't quite as accurate or where there's more uncertainty. And that also works with the data that you have available, because you can get kilowatt hours of electricity and find emission factors for them. And reporting would be sort of the end result when you're done. We don't really need to talk about that in depth. So this formula summarizes the mathematics that I just described. This is the core of the process, and this is really where the magic happens, where you can kind of get to a place where you actually have numbers to report. And so when you're and I noted that when you're a small business, it can be hard to find the time and resources to work through this accounting, whether that's staff time or paying a consultant, or sometimes even interns to sort of help with at least data collection. And there are some tools, simplification tools you can look at rather than having to crunch all the numbers yourself in a spreadsheet. And so I know frequently I notice that there can be some confusion on kind of how emission factor and global warming potential pan out. So let me go into depth on the example that I've been going through, burning a gallon of gasoline. These emission factors are telling you for each gallon you burn, you get 8.78 kilograms of CO2, and then trace amounts of CH4, which is methane, and N2O is nitrous oxide. And then the global warming potential is the heat trapping, or the CO2 equivalents of each of those gases. So CO2 is one, and then the others have higher emission factors because they're more potent as greenhouse gases. So then the mathematics is you just multiply each amount of gas by its global warming potential, then you add them up. If you're familiar with Excel, that would be a sum product function. But either way, you can just sort of, even if you had to manually do this and you didn't have software, that's how you would go about calculating what the footprint of that gallon of gasoline is. And you see it comes in at 8.81 kilograms, which is only slightly more than the 8.78 of CO2. And that's partly because there's just very small amounts of those other gases. But we still do need to look at, kind of take them into account. And so if you do all of that successfully, you'll get results. And this is actually from an outdoor goods company, but they are working with metals and plastics, so there'd be some similarities. So they have a headquarters in the US, a manufacturing site in Vietnam, and an office in Kenya. I also see, I'm running maybe a little short on time, so I'll probably sort of expedite this so we can get to some of the LCA and specifics for small and medium-sized jewelers that I think we want to get into. But essentially, this is what you'd look at. And this also helps you start to look at what's significant in going into reduction strategy. And so what this is telling you is if you want to make real progress toward an ambitious goal, you'd have to touch the Vietnam electricity, because you can't reduce more than 30% if you don't touch that, because that's 70% of your footprint. And then you zooming out to scope 3, there's a lot more emissions involved with raw material sourcing. What we just looked at for scope 1 and 2 is actually just that very small wedge at the top in dark brown. And you see that's dwarfed by raw materials, packaging, co-packer energy, and other things, which I suspect for most manufacturing, that's the case, that it's a lot of what you're purchasing and how you're processing it does end up being kind of a big portion of the footprint. So let's get into some specific issues with smaller organizations. So one issue that can often come up is like shared rent spaces. So you might want to use utility bills to come up with your footprint, but your landlord might control that. You may not have individual metering on your space. So if you don't control the space and you don't get utility bills directly, that's sort of a problem. If you could find whoever is paying the bill, in theory, you could prorate that based on square footage. And if you have reason to believe that one of the tenants actually has exceptional energy use, like they're a glass blower and you're making jewelry and they're having to heat a furnace up, you could try to take that into account. But if all that fails, what you can do is use metrics like this to estimate usage without utility bills. And so these are benchmarks that the Department of Energy provides, where they basically said for each of these different types of businesses, and they actually have a lot more breakdown in terms of building size, where you are in the country. I'm only showing a portion of it, but there's like different sorts of office activities and other retail. They're not going to have specificity to like kind of a jeweler characterization, but you can use some metrics. There's a per square foot, it's 4 columns over from the right that you can use as sort of an estimate. So if you know how much square footage you're using, you could apply metrics like this to come up with an estimate of your footprint in the case where you don't actually have utility bills. And I mentioned earlier, so small businesses aren't going to have budget for consultants. You might not have budget for software, and you might not have a lot of bandwidth to actually figure this out yourself. So you can start with estimation tools, and this is a freely available calculator called Normative, or it's a business carbon calculator, I guess, from Normative, in part sponsored by the UN, which has this SME climate hub where they've encouraged small companies, and I'm also a small company, and we signed up for SME Climate Hub, so I can say us, where we sign up and you get access to this tool and you can run your footprint. And so tools like this, they're making pretty rough estimates. I ran this for ourselves, and based on revenue, based on square footage of the space, it came up with sort of this estimate of footprint. And you see most of that they found was sort of scope 3. So that's 14.2. And then the direct emissions were quite low. I believe with direct emissions, they take actual utility information. So it can be a start. One challenge with this is it's not very granular in terms of, I think it's only based on income. So like your emissions go up if you make more money, it goes down if you make less, and it's not really accounting for whether some of what you're spending money on is a lot more greenhouse gas intensive than others, but it is sort of can give you sort of first estimate.
David, can you pause for one? We have a clarifying question. We'll get to the substantive questions later.
Yes,
Clarifying on that last slide that you just showed, what is that number, the 14.6?
Oh, this right here? That is the total scope 1, scope 2, and scope 3 footprint for climate positive consulting.
For the year?
For a year, yes. It's the time
year.
period in the 2023 is the estimate.
Right. And in tons.
It's in tons of emissions, yes. Tons of CO2e. I guess it's a little small. It's right here. Here's the year range.
Oh yeah, it's small. And how, just for everyone, like how does that compare to an airline flight, like an international flight?
International flight would probably be another 2 to 3 tons. So this would be a handful of them. I mean, it depends on how far you're going.
Mm-hmm. Okay. Thank you.
We could get into the flight emission factors, but yeah, it's. And we'll stop for questions and answers. I know I've been talking a lot, but we'll have time for questions and answers, I think, here shortly. So where you have control of facilities, it's relatively straightforward to get data. A common problem across industries is that you don't have supplier facility data because you don't manage those facilities. So if you're sourcing gold from some supplier, you're not going to have necessarily a lot of access or leverage on that manufacturer to give you information on how much energy they used, let alone going back to like sort of the mining site and understand kind of what the energy use is at that site. And a problem for a lot of organizations is that they actually don't know where supplies are sourced from because you're working through intermediaries and they could be sourcing material from any number of places. And this is sort of just a common traceability problem that comes up in sort of a lot of industries. I know it comes up in jewelry, but there's many others, food processing and others that don't always have information on sourcing. So because of that, we need to use estimation techniques to come up with the footprint of things that we purchase. And so typically the way we'd come up with that is that it's called sort of a life cycle assessment. It's sort of the process. But the idea is that whether you purchase a diamond, a wrench, a bolt of cloth, or an end table, there are greenhouse gas emissions associated with that purchase. From that sourcing of raw materials to the processing and packaging to transport or possibly storage before they get to you. And so the process you go through to come up with that footprint is kind of a modeling exercise called LCA, where you're trying to get all the inputs into that process to the extent that you can and come up with footprint. So this shows you the user interface for a lifecycle assessment software program called OpenLCA. It's what I use to run lifecycle assessments, and it's not particularly user friendly, but LCA is kind of complex. And what you're seeing here are all the inputs done for gold production. Essentially, this is looking at all the inputs required to get a finished kilogram of gold. And most of this is coming from academic studies that have been done. That's a lot of what feeds LCA. It could be industry, it could be, a lot of it comes from the university. So what this is showing you is, says for every kilogram of gold, there's almost 17 kilograms of charcoal. There's 16 kilograms of what they refer to as blasting, but it's sort of an equivalence, an equivalent amount of, might be dynamite or something. I'd have to look at it. There's an amount of energy and diesel that's used, and everything else that's shown here as inputs at this specific mine. So after you've had this, and there's some OpenLCA will have some sort of already sort of baked in estimates. So this is already the results of someone's work. If you had better results, like you had worked directly with the mine and you knew the amount of diesel they used was different to the amount of charcoal, or some of these inputs didn't apply, you could adjust these and run something that's specific to your process. Once you're comfortable with the inputs, you press a few buttons and you get this. So LCA gives you a range of environmental impacts that you see on the left. There's climate change is the second through fifth rows. Acidification is talking about thinking about like acid rain, like how much this would contribute to acid rain. There's also ecotoxicity and some other metrics that honestly start to get kind of obtuse, or they start to leave sort of the plane of reality in terms of how understandable they are. I mostly use LCA for climate change, and that's partly because kilogram CO2 is relatively equivalent because enough of us have worked with this as a concept. But if you were looking at this, even if you were looking at this fresh, it's like kilogram CO2, what does that mean? And kind of like Christina sort of asking, it's like, well, how many airplane flights, or how do I put that into context? Some of these other measures also would need better context too. And so we're here to discuss carbon footprint. I'm not going into a deep dive otherwise on those other metrics. But actually, one thing I guess I should say. So what this is saying is sort of the fossil climate change footprint that's circled here is 11,551 kilograms to produce 1 kilogram of gold. Which, if you compared that with a lot of other things like foodstuffs or even something like copper, is huge. This is a very big footprint per kilogram, but it's partly speaks to just how scarce gold is in the environment and how much work we have to do to extract it. And again, if you had a place where you knew there were artisanal miners panning for gold and it was just flowing out of the hills, you could have a much lower footprint, but you'd just have to have the data where you could sort of adjust this this analysis. So I just want to compare a couple different sources that we have. So in different studies can get you different results. So the bar on the left represents what we just looked at, which I understand represents larger scale mining and is from a study that's at least a decade old. The footprint, I think this footprint, there might have been a little slightly different approach, but it's close to that 11,500 we just looked at. It looks like it's probably just over 12,000. The bar in the middle is from the findings of a more recent study on artisanal mining, and Christina had actually shared this with me a few months ago, where so it's artisanal mining in Brazil, and they sort of came up with a footprint that was 16,000 kilograms of CO2. So in the same ballpark, which to me is actually sort of a form of validation if you have studies that are roughly showing the same thing. You would expect some natural variations because electricity could be cleaner in some places, or you might have relative efficiencies depending on how rich the deposits are. How rich the deposits are is sort of a huge driver in how much yield you get from your effort. And then finally on the right, we have the footprint of recycled gold, which actually is from analysis of the treatment of electronics scrap, actually. So it's post-consumer, but it's electronics, not jewelry. And then the effort that's needed to extract precious metals. It looks pretty small, but that's over 1,000 kilograms of CO2 per kilogram, which is still quite a lot. If I was comparing this to copper or zinc, it would be quite huge. And so depending on what you know about sourcing, you could choose to apply either of these, depending on what most speaks to your circumstance. And then I see where I'll try to leave at least 20 minutes. So I'm just about done. And just as another example of that, here's the results of a range of studies we looked at a few years ago on copper. And again, I would consider these relatively in the same ballpark, like they're all the same order of magnitude, but you do see some variation. And if Chile has richer copper deposits than other countries, this actually could make sense. And what usually what you would do is, like, if you know you're sourcing from Latin America, you would use sort of the Latin America versus Asia Pacific, et cetera. It's also possible you might find reasons that some of these others, like maybe even though you're not in Chile, the way mining happens in Chile or the type of deposits you have might mean it's more like Chile. So there's some professional judgment that would go into choosing which to use. And the other thing I'll say, so the footprint here is like 2 kilograms to 8 kilograms, and compare that with the 1,000 and 10,000 we were just looking at for gold. And then just quickly, so part of that artisanal mining in Brazil, they actually looked at several different mines, and they managed to get data on how much diesel is used per site. And what this is showing you is that the amount of kilograms per kilogram of gold varies about by a factor of 2. If you look compared E17 with E18, that's kind of like a factor 2 difference. Generally, you're not going to know exactly which mine your material is coming from. If you did, you could use the specific mine, and generally you're probably using this default. The bar in the middle represents sort of the average, that 4,410 kilograms of diesel per kilogram of gold. So you'd probably, if you were building your own LCA and needed to go back to the inputs, that's probably what you would use. Okay, you've listened to me for a long time, so thank you. It's hard to do justice to the topic because there's a lot going on, and I have broader courses that also handle this topic. And even in the 10 to 20 hours sometimes we have with that, it's hard to get into everything. But this is sort of hopefully a good start, and I both showing some jewelry specifics as well as the general process. So let me stop there and take questions.
Yeah, David, phenomenal. I think for the majority of us, I won't speak for anyone in particular, you really categorized the different methods to think through. You gave us resources, like from big to specific, and we just ended on this really specific note. So I just really appreciative of the way that you structured it so that we could understand numbers that we're seeing thrown out in the world, about these topics to what might apply to our particular businesses. There are some questions that have come in from the chat that are, as we predicted, quite specific. And because some of the things that people want to know is like, what's my better choice? So in fact, it's like the facility question seems not to be the biggest priority for people, like my own studio practice or my communal studio or the manufacturer I source from, but people really want to know the specifics about the materials themselves. So if you're willing, can we kind of dive into some of these more specific things? And I'll hand it to Anna to pose the questions, and I'll just help with moderation.
Well,
Okay,
that
great.
sounds fine. And your since facilities are going to be a fraction of probably your source material, that is logically the place you'd want to look.
Yeah, thanks.
Yeah, wonderful. Yeah, I will just second. That was a really excellent presentation. I definitely learned a lot. So thank you for that. I'll just go in order of the questions that we received so far. So the first one was from Christina Mall. She said, I'm curious to hear how David would consider a lab-grown diamond company that claims to be green because it makes carbon offsets. Does the world of carbon offsets actually help reduce carbon emissions globally over time? Or has it merely created a market for trading offsets? How do we, as lay people, assess claims based on carbon offsets versus claims based on carbon reductions?
Oh, great question. I think it's always thorny to call yourself green or sustainable because you always have to ask, well, what does that actually mean, and what does the definition mean? So I guess maybe to start, so there is an ISO standard that actually has some guidance on how you do carbon footprinting. And one thing they say is offsets, you can't just offset your footprint and say there's kind of no carbon footprint. So if you look at because you have to look at the chain of everything, all the inputs that are going into sort of making that lab grown diamond. So, what material you're sourcing for carbon, and what's the upstream impact of that? How much energy are you using? Because it's going to be a very electricity intensive process.
Mhm.
And then actually look at what the yield is. So that would be your carbon footprint. If they choose that they want to say they're carbon neutral after that they certainly can do that and go and source offsets. But from a carbon footprint standpoint, wouldn't say that their footprint is zero. You'd say their footprint is what it is. If they want to buy carbon offsets, they can do that. If they want to source renewable electricity, there's a little more value there because there's that you have flexibility in how you sort of claim that. But it wouldn't be a zero footprint for in that case.
Mhm.
And for all
And
these,
that would be through,
sorry, go
just to
ahead.
clarify real quick, that would be through renewable energy credits?
Renewable energy credits, accounting does recognize renewable energy credits. So you could buy, and renewable energy credits do have some functional, like qualitatively, they're similar to offsets in some ways. But the difference is you're sort of you're sourcing electricity somewhere else in your local grid. You're investing or at least claiming credit for renewable electricity. So it's a little different than, I have all these energies going into my lab grown diamonds and I'm going to buy trees in India and call it good. Like there's at least a little more better match in terms of footprint.
Okay. And then the rest of that question, sorry, I interrupted, so maybe interrupted your thought process, but kind of about offsets more generally. And I think this is kind of getting at like the efficacy, like, is it actually helping reduce carbon emissions over time? I guess if you have an opinion on that, like
Sure.
how valid it is as a claim.
Offsets certainly can remove carbon or slow future carbon, what they call avoided emissions in the future. The point is you don't have a guarantee. A lot of the offsets are like future looking. So you're planting trees and hoping they survive for 40 years, or you're investing in wind turbines that are going to operate over 25 years. And this is almost like a philosophical point on it, but there's sort of like matching time frame is sort of an issue because you have like these historic missions you've always created, and now you're trying to invest in projects that are going to remove it. And that's why there's a lot more interest in carbon removal, which is also a lot more expensive because they better reflect the actual cost of doing it. I guess the other thing I'd say, so my whole practice is really focused on reductions. So we're working with companies to go through the accounting, look at things like setting a science-based target, which is kind of this ambitious greenhouse gas reduction target. And part of the real strength of science-based targets is that it actually requires reductions and it doesn't recognize offsets. That said, everyone gets led toward offsets because after they do everything they can, some people want to try to make it climate neutral or show, I think in a well-intentioned way, want to show that they're creating other environmental benefits. And so I make the case, if that's something you want to do, you can look to invest in offsets that are like creating economies in kind of global South countries that you want to support, or create forest habitat that has like a multiplicity of benefits. I think you can be intelligent about supporting projects that seem like they're good things to support. But I just wouldn't hinge an entire climate strategy on offsets because it's not going to be viable and you're going to be under too much scrutiny from stakeholders that know enough about the issue.
Yeah, that makes sense. Great. So the next question we had, I feel like kind of you're in a way going in this direction of like we're talking about like what is most effective. Christina Vegas asked, can you comment on your knowledge of carbon insetting in various supply chains and what you see as potential inspirations for jewelry to learn from?
There's have been some questions on the definition of inset, but as I think about it, it's a project, whether that's carbon reduction or carbon removal within your own value chain. I think those would actually count for your carbon accounting if you can show that actually reduces the footprint. So if you're installing renewables at a supplier site or helping them install LEDs or potentially, let's see, what else would be a good example? It could be lightweighting packaging. There's a lot of different things that I think you could do within your own value chain that actually would shift the numbers. I think I may have missed an aspect of the question though. So can you restate it?
I think what it's probably mainly getting at, and Christina, if you'd like to come on and clarify a little more, you're welcome to. But what I'm kind of thinking about with this question is, I think kind of this idea of having a more direct impact, like you were saying, with the offset, that's kind of future looking, and who knows how much impact it'll actually have. Whereas, if I'm understanding the process kind of correctly, insetting being more about having a more direct and more immediate impact on reductions in your value chain. And the other part of the question was, are there examples out in the world that you've seen from maybe other industries that jewelry can kind of look to use as an example? Yeah, go ahead, Christina.
Yeah, so I'm Christina Villegas with an NGO called PACT, and I work a lot with mining host communities. And I have some peers on this call that I work with gold. I work a lot with gemstones. So we're doing some innovation, and just we can always learn from others. And so I was wondering if you have examples that are truly excellent, that as we develop our kind of response, to help host communities benefit, from the sustainability trends. What are ways that the other industries like timber or like paper and others that have innovated that within their value chains that might be inspiring for us?
I guess what I'd first maybe look at is sort of the specifics of the different community. And again, I'm kind of geared toward carbon footprint. So there could be other benefits that happen in these communities too. But is it like a lot of diesel use that's happening in mines? You can find sort of bio-based versions of that have better emissions profile and actually would have kind of different greenhouse gases, but maybe even better than that is like, are there ways to actually electrify the process? So you're also not exposing people to all those emissions, because we just saw 4,000 kilograms of diesel per kilogram of gold. That's a lot of diesel. Mm-hmm. I think your broader question is good. I think I'd need to give that more thought if there's like sort of kind of really good examples. I work a lot with the food processing industry. So there's a lot of looking at regenerative agriculture, where you're trying to build soil carbon kind of at the farm level and seeing if there's ways to compensate. Actually, farmers can actually get compensation for some of those better practices. So whether there's something analogous for mining would be an interesting thing to think about.
Yeah, we're looking into that. Cool. Thank you.
Yeah, I was going to say that seems very applicable to restoration of past mine sites, for example. Okay, great. So the next question we had come in from Patrick. I'll read it fully. In our industry in Europe, the vast majority of the gold comes from unknown origin, old coins, bars, or jewelry. The refiners and brands consider that this gold accounts for zero carbon as they consider it recycled. However, for some, an old coin, bar, or jewel are not waste, contrary to an old mobile phone, for example. Are they doing the right thing by accounting those inputs for zero and just taking the refining process footprint? So I think this is kind of speaking to the fact that, when you have old jewelry that is melted down and called recycled, is it really fair to kind of start over the life of that piece when it wasn't really going to go to waste in the first place?
So that's, yeah, no, also a great question. I think there certainly can be with else, if we talk about specifically LCA, because that's kind of the process where you come up with this, there are places where different well-informed people could actually make different assumptions about how you come up with sort of the greenhouse gas footprint. So whether in some cases you have like byproducts and you have to like look at, okay, we have two products coming off of this, how do I allocate? Recycled material is tends to be kind of across a lot of industries or a lot of different materials, one of the more complicated things, because there are different assumptions you can make. So if you actually had old rings, there in theory would be some energy needed to just collect the ring. I wouldn't expect that to be a lot, but you'd have like some transport to a refinery. You'd have the refinery inputs. And then you'd have kind of your finished product. So I wouldn't, I think in some cases, saying the material is zero footprint because whoever bought that ring, maybe 50 years ago, you could allocate the footprint of the actual mining, the original mining process should go to that, because I don't know that there was an expectation 50 years ago it would even be recycled. So they sort of have responsibility for that. So if you're just picking it now, I think you could credibly say that the footprint of the material itself could be zero, and then it's mostly just about transportation, refining, anything else that needs to that comes into play to actually like create a new piece out of the old piece. The example I did show you was from treatment of electronics waste, and I guess I'm also hearing that maybe there's a concern on sort of the definition of the terms. I'm less concerned about whether it's defined as sort of a waste or a byproduct, unless that's actually tied to different assumptions you have to make on around the LCA, and more about looking at, so what's physically happening here? How much energy is being used to expend this? And if I don't have to move that ton of rock to get the gram of gold and someone's already kind of brought it together in a piece, and it's been that way for decades, I think it's reasonable to say that that you're not necessarily allocating those original footprint, but different people could have different takes on that.
Mm-hmm. Yeah. The example you're giving makes sense to me. I think where we run into issues in the jewelry industry is those definitions, because they definitely allow for that gold ring might have been mined last week or the manufacturing scrap might be mined last week. So I think that if we were able to know for sure that that piece of jewelry or whatever is going into the recycled source has actually had a long lifespan out there.
Yeah, that's a good point.
Comes back to definitions for us.
Yeah, I was assuming this was post-consumer, and I was assuming not too many people are buying a piece of jewelry and getting rid of it the next week. So yeah, that's certainly a different scenario.
Different scenarios. Okay. Okay, great. We have 5 minutes left. Let's see if we can get through a couple more questions. Charlie Espinosa asked, the GHG calculations I've seen, including from the World Gold Council and the study in Brazil that you mentioned, do not include emissions from deforestation. Do you think that this oversight is significant? And I would add to this too that, and actually maybe Christina, would you want to speak to this question a little more in depth real quick about kind of seeing new numbers about like the different depths of mining as well?
Well, just to say that we're waiting on a report that analyzes the release of carbon, not just at the time a tree is cut, but also the release when the soil is removed from the surface, to digging a meter or so down, to digging 3 to 4 meters down, and how under tropical forests, 3 to 4 meters under the forest is like the equivalent of coal. In other words, it's so old, the carbon that has been stored in those sediments for over time are so old that it actually becomes like a quadruple fold release of carbon at that point. So I'm not the scientist. We're waiting to see, what those numbers are, but Charlie and I, in transparency, our consultancy works with an organization called Amazon Aid, and Charlie and I work together on a project developing a Amazon Gold Working Group, kind of an international stakeholder group. So this question is kind of coming from there. So go ahead, Charlie. I saw you went on camera and unmuted. We'd love to hear from you.
Oh no, I actually would just like to hear from David. I think that's a good introduction, Christina. Thank you.
So there are sort of emerging land sector and removal guidance that the Greenhouse Gas Protocol has been working on for a couple of years now. And partly because there is a huge concern that just in general, not jewelry, but broader industries and industries where it's actually like forestry or agriculture, where you can imagine there's a lot more kind of land use, I think, concerns at play. So they've been working on guidance because there's sort of a couple different aspects of it. I'm pretty confident it's actually not getting to the nuances that you just described, like how deep you're going and how old some of the carbon is, because carbon that old actually sounds more like a fossil. You treat it as more of a fossil fuel. One thing I can say with at least science-based targets is they're requiring no deforestation pledges, and as part of that, there's this other guidance that's supposed to lay out how we actually incorporate land use change into it. So there's ways to go about doing it now, but for that specific category, I think the only thing I'd say is yes, if you're driving land use change, you're converting it from forest to agricultural land or forest to, I guess, cleared land for mining, I guess would be pretty extreme. You need to take those into account, and in theory, they will provide emission factors that would actually say what the emission factor loss is. But I think studies like you're just saying should actually inform that for mining, and I would hope would sort of factor into it, because I think what you're describing seems like a different level of impact than I think is going to come out of other studies of the topic. Sorry, I don't really have more on that, but that land use in particular, I think, is one of the real complexities around this, because burning fossil fuels, we kind of understand that you can measure carbon dioxide, but land dynamics is a lot more complex.
Thank you. What do we say? We're at top of the hour.
Yeah, we have a couple more questions that I think, if David, if it's okay with you, maybe we could have you answer them in writing and share them in the blog post.
Sure, that works. Okay,
that'd be great. Yeah, Christina, go ahead.
Just to say thank you. What we do try to keep within the 1 hour time frame, and your questions were all very insightful, and we will circle back with David to get responses and include those in the takeaways. We always publish them on the website. You also get them in an email. So thank you very much for joining us today. A reminder that because we do this every other month now, our next session is not until July, and it's not the 3rd Friday of the month, but the 4th Friday of the month. And Christina Villegas, who's on the call with us, is going to be our guest, shedding some more light on that insetting concept and other topics around colored gemstones. So we're going to be doing a little bit of a deep dive on this introduction that David so generously gave to us. Big thank you to David for the time that you took to put this information together and bring it to this very specific audience, and for the work that you're doing to stay up to date on all of this. It's a moving field, and we're really appreciative that you shared it with us today. And thanks again to everyone that contributed to the living room session. Have a wonderful
great
day, everyone. Great seeing you.
Thank you all.
Great weekend.
Thanks,
Ciao,
everyone.
ciao.